Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about one more example of marginal density functions of x and y and also determine constant b value. This is the previous examination question. The example is given the function fxy of x comma y is equal b into x plus y whole square for x is equal to minus 2 to 2 and y is equal to minus 3 to 3. And fxy of x comma y is equal to 0 elsewhere. First bit, find a constant b such that this is a valid density function. And second bit, determine the marginal density functions fx of x and fy of y. Coming to the solution, given that the joint density function is fxy of x comma y is equal b into x plus y whole square for x is equal to minus 2 2 plus 2 and y is equal to minus 3 2 plus 3. So given density function is a valid density function. So find out the constant b value using property of the joint density function. That property is integral minus infinity to infinity integral minus infinity to infinity fxy of x comma y dx dy is equal to 1. So using this property we can determine constant b value. Now applying the given data on LHS side. So given that the range of the x is minus 2 to 2 and range of the y is minus 3 to 3 and joint density function is b into x plus y whole square dx dy is equal to 1. So now here applying the a plus b whole square, that is equal b is constant, that is written before integration, b integral minus 2 to 2 integral minus 3 to 3 x square plus y square plus 2xy dx dy is equal to 1. Applying the double integration into each term, we get b into integral minus 2 to 2 integral minus 3 to 3 x square dx dy plus integral minus 2 to integral minus 3 to 3 y square dx dy plus integral minus 2 to plus 2 integral minus 3 to plus 3 2xy dx dy is equal to 1. So in the first term, integrating with respect to x and with respect to y. So this first integral term can be arranged as all are the product term. So this first term can be arranged as integral minus 2 to 2 x square dx integral minus 3 to 3 1 dy plus similarly here also second term all are the product term. So this second integral term can be arranged as integral minus 2 to 2 1 dx integral minus 3 to 3 y square dy plus 2 is constant, that is written before integration 2 into. So similarly this third integral term is also arranged as integral minus 2 to 2 x dx integral minus 3 to 3 y dy is equal to 1. So now integrating with respect to x and with respect to y, integral x square dx is x cube by 3 over minus 2 to 2 integral 1 dy is y over minus 3 to 3 plus integral 1 dx is x over minus 2 to 2 integral y square dy is y cube by 3 over minus 3 to 3 plus 2 into integral x dx is x square by 2 over minus 2 to 2 integral y dy is y square by 2 over minus 3 to 3. So now substitute here upper value of x and lower value of x. Here also substitute upper value of y and lower value of y. So similarly in the second term and the third term also substitute upper value of x and y, upper value of x and lower value of x and upper value of y and lower value of y and reducing RHS term. Finally we get the constant b value is 0.0059 and this is the first bit solution. Next coming to the second bit, and second bit is determine the marginal density function of x and marginal density function of y. First calculate the marginal density function of random variable x. We know that the marginal density function of random variable x is fx of x is equal integral minus infinity to infinity fxy of x comma y dy. So this is the basic expression of the marginal density function of random variable x. Now here applying the given data, fx of x is equal, given that the joint density function is b into x plus y whole square and y is equal to minus 3 to 3. So applying the a plus b whole square, b integral minus 3 to 3 x square plus y square plus 2xy dy. Applying the integration into each term, we have fx of x is equal b into integral minus 3 to 3 x square dy plus integral minus 3 to 3 y square dy plus integral minus 3 to 3 2xy dy. So now we are integrating with respect to y, x parameters are the constant. In the first integral term, integrated with respect to y, x square is constant. X square into integral 1 dy is y over minus 3 to 3. And the second integral term, integral y square dy is y cube by 3 over minus 3 to 3. Here the integrating with respect to y, 2x is constant. 2x integral 1 dy is y square by 2 over minus 3 to 3. And after that, here substitute upper value of y and lower value of y in this term, in this term, in this term, and after that simplifying the RHS term, and b value already calculated, substitute that b value into here. The marginal density function of random variable x is 0.03 x square plus 0.09 x plus 0.107. So next find out marginal density function of random variable y. So this is the basic expression of marginal density function of random variable y. So in this equation, applying the given density function, given joint density function, fy of y is equal, the joint density function is x square plus y square plus 2xy for x is equal to minus 2 to 2. Applying the integration into each term, we have b into integral minus 2 to 2 x square dx plus integral minus 2 to 2 y square dy plus integral minus 2 to 2 2xy dx dy. So now here the integrating with respect to x, y parameters are the constant. Integral x square dx is x cube by 3 over minus 2 to 2. So y square is constant. Integral 1 dx is x over minus 2 to 2. 2y is constant. Integral x dx is x square by 2 over minus 2 to 2. And after that substitute upper value of x and lower value of x, simplifying the RHS term, and also substitute b value. Finally we get the marginal density function of random variable y is fy of y is equal 0.02 y square plus 0.04 y plus 0.031.